This is a video of our tree canopy data shelter data logger. So here is our installation location. It's located inside the pipe enclosure on the tree canopy shelter. And there's an abstraction of what our flow sensor will look like. So it starts off with a filter to filter out any debris. Then it will go through a hose adapter to bring it down to a 1/4 inch hose. Then it will be fed through the water flow sensor, another 1/4 inch hose, and then the 3-inch tubes of the actual rainwater pipe. And there's a soil sample. And then our circuit board, which contains all the hardware. This video will give you an introduction to the components we used, give a sensor functional demo, and then give a data visualization demo. So first, an introduction to the components we used. We have an Arduino Uno microcontroller, which runs all the source code, a set of lithium-ion batteries to power the entire project, a DHT22 air temperature sensor and humidity sensor. There's a breadboard with all of our hardware on it. We have a charging board to charge the lithium-ion batteries. We have a buck converter to step up the voltage to 7.8 volts so the Arduino can accept it. And finally, an ESP8266 Wi-Fi chip. We also have a soil temperature sensor, so there's the soil. And then there's a soil temperature sensor, which is a probe that rests inside the soil. Here's our water flow sensor, which is connected to 1/4 inch tubing. And secondly, we'll give a sensor functional demo. Here we'll demonstrate the DHT22 air temperature sensor and also our soil temperature probe. So as we're updating the temperatures read on the Arduino IDE serial monitor. Here's a closer view of the actual air temperatures. So we have a 21.4 degrees Celsius air temperature and 21 degrees Celsius soil temperature. Here's a demonstration of the water flow sensor working. First, we pour water through the funnel, and then it'll essentially turn the wheel in the water flow sensor, which activates a Hall effect sensor. As you can see, it's registering flow rates of 0.5 and 0.4 liters per minute as it's running through the hose. And there it's draining into a Tupperware container. Lastly, we have a data transmission demo to see how data is actually pushed to the website. So here we have an ESP8266 Wi-Fi chip, and this is the serial output from it. So as you can see, it's got its IP address, and now it's connected to the access point. And then it'll use an HTTP GET message to push data from the sensors to this IoT website. So when we go to look at our channels, and then to our project, we can see the output of the graphs over time. Now here we've logged all our data for just over this day, but it can be changed to different time periods. Here we can see the air temperatures and the air humidity, soil temperature, the water volume, and the water flow rate through the flow sensor. In addition, we can look at the actual location of the bus stop on the Google Maps utility. Thank you.